only one process can enter in the critical region. This is a program, but although this program aims achieve mutual exclusion, but there is a problem about busy waiting. This comes because the while loop needs always check whether a value, for example, the variable term is to be 0 or 1. To solve the busy waiting problem, we have learned the producer-consumer problem. In this problem, there are only two processes. One process is used to produce items, and the other process is to fetch items from buffer. These two processes, producer and consumer, share the buffer. The producer just put an item into the buffer, while a consumer is to fetch an item from the buffer. So we just use sleep and wake up, and it means when there is none item in the buffer, the consumer becomes to sleep because the consumer can't fetch any item. On the contrary, if the buffer is full, then the producer should go to sleep, because although even this producer generates an item, there is no slot to store this item. This is the basic concept about producer and consumer problem. In this program, we use two variables and count to record some basic information about the slot or items in the buffer. But we will find that in this program, the wake up signal may be lost. This is because we didn't present a constraint on some variables, for example, count. So a way to solve the problem is to use the semaphore. Semaphore is a spatial data type. It is an integer, and then the value of a semaphore is equal to or larger than 0. If its value is larger than 0, it means there are some processes want to wake up these processes. Just to record the wake up signals. So we just do some modification on this program. There are 3 variables in the new program. Okay. In this chapter, we will learn some basic knowledge about scheduling. We have learned that there are many processes in our computer system. Yes. So when and how to select a process to run is just the goal for scheduling. The scheduling aims to select a process to execute. So we call it scheduling. Let's focus on this figure. There are 2 types of process. The first one, the above one, is a CPU bound process. Maybe we can call it a computer bound process. The process at the bottom, this one, is an I/O bound process. So from their names, maybe we can get some information. Okay. For example, CPU bound process, it means that this process require many time for CPU. Yes. Okay. And the I/O bound process, it means that this process requires many time for I/O input output. We know that the process mainly has two types of tasks, CPU and I/O. Yes. Okay. Occupy CPU or I/O. I/O is to read or write data. Yes. CPU is just we require the CPU to do something, for example, for computation. Okay. So in fact, a process is for CPU or for I/O. Okay. CPU and I/O. So if a process is called a CPU bound process, it means that most of the time of the process is used to CPU, for example, computation. Okay. This one means that most of the time of this process is used for CPU. For example, we ask the CPU to do computation. Okay. So a CPU bound process is also called a compute bound process. On the contrary, the I/O bound process, it means most of the time of this process is required for read data and write data, input and output. Okay. So we can see in this figure, the shaded area represent CPU burst. And it means that this process requires CPU burst. Okay, shaded area, CPU burst, and the line between two rectangles, a line represent I/O. Okay. So we can see that most of the time of the first process is for CPU burst. Yes. Is longer than the length of the line. Yes. So because the shaded area means CPU burst, so we can get that this process spend most of its time for CPU burst. Yes. So it is called a CPU bound process. On the contrary, the second one, we can compare the length. This means this axis is just the timestamp. Okay, time goes by, timestamp. We can see that first CPU burst, then I/O. Waiting for I/O, CPU burst, waiting for I/O. CPU burst, waiting for I/O. The length, we can compare the length. The length just present how long are required, yes. So we can summarize the length of the shaded area, and we can also summarize the length of the lines. It is obvious that the length of lines is longer. It is obvious the length is longer, yes?
Yeah.
It's longer than the length for shaded areas. Yes, so we can make that most of the time is used for I/O. Okay? So the difference between these two processes is obvious. The first one is a CPU bound. The second one is I/O bound. Okay?
Switching from one process to another.
Yes. Before we get steps into scheduling, I think we should have the basic idea. Since there are multiple processes in our computers, so in fact, the operating system just switch from one process to another process. Yes.
Yeah.
Because there are so many tasks to be executed. So just from one process to another process. So we could get switching from one process to another process. And the switching from one process to another process is expensive. Okay. When we have long processing, we learn that there are many information about the process. For example, its stage, yes, stack, okay, and its own data, yes. So when we switch from one process to another process, we should restore the stage and the basic information about the former one. Yes, everything we should store and record. Okay, because we may return back to this process. So it is expensive. Another thing, when the operating system switching from one process to another process, as I just said, there are some things we have to do. So we should require some time. Yes, if there are many switches, that is, if the switch is frequent, it means that we will lost many time for the switching. Okay, so the utilization, the CPU utilization will be low.
Yeah.
Okay, let's learn some algorithm about scheduling. So first, we should know our goals for the security analysis. This is because first we should know our purpose is what, yes, and then maybe we can design a program.
Make a plan, design.
Yes, make a design. Okay. There are different computer systems. For example, batch system, interactive system, real-time system. We have learned batch system. It means some tasks are executed at all. Okay. This is the interactive system. Interactive system means 交互。Means for example, when we use our iPhone, we buy something, maybe we pay the money using our face recognition, 人脸识别. So if we want to pay money, we first have to take a photo, use its app. Yes, this is the interaction. This means the user should do something, and then the program get all information, and another to do something.
Like WeChat payment or Alipay payment by fingerprint. WeChat payment 付款，微信付款和支付宝付款在 fingerprint.
Yes, okay.
Yeah.
Maybe you pay the money, you use WeChat or Alipay. Yes, you can use face 人脸 recognition, or you can also put it into your password.
Fingerprint.
Yes, fingerprint, password. Okay, maybe you read something others. Okay, this is the interaction of the system. Program becomes the next thing to do after he
get response from user.
Yes, for example, when you pay the money, use your fingerprint. It must first read your fingerprint and determine whether the fingerprint is your own. Okay, and then do the next thing. If the fingerprint is yours, then you can pay money.
Yeah.
Otherwise you can't. Yes, this is the interactive system. The last one is the real-time system. It means that the response time should be short. In fact, when we use multiple programs, we want to get a quicker response. Yes, we don't want to wait too long time. Okay, the response time should be short. Okay, response time. For example, if you play games on your computer, you don't want to wait too much time. Yes. So different systems may have different goals.
Yeah.
There are some goals are very important for all systems. For example, fairness. Fairness means that giving each process a fair share of the CPU. Just like the name showed, one process can use the CPU and another process can also use the CPU. We can't block another process and prevent the process to use CPU. It is unfair, yes. So the first one is fairness. The second one is policy enforcement. There are some policies for the system. So So because this is the policy, so the policies will be carried out. The third one is balanced. 平衡 Yes, 平衡 keeping all parts of the system busy. Our system is composed of multiple hardwares, many parts. We should balance the workload of all parts of the system. Especially for the batch systems, there are some other goals. For example, throughput. It means per hour, the jobs that can be completed should be as many as possible. Complete so many jobs. The second one is the turnaround time. We can see that the turnaround time is just the time between submission and completion. We should minimize this turnaround time. The third one is the CPU utilization. We have learned a figure about the CPU utilization. That means when I give in a period, we want the CPU is always busy. That is busy all the time. This is the CPU utilization. For the interactive system, the most important goal is response time. I have just give an example. When you play games in the computer, you want to reach the response quickly. So this is to minimize the response time. The second one is the proportionality, just meet the user expectation. So because this is an interactive system, so we should pay attention to users' expectation. I have just used the example for paying money. Just use our face figure and our fingerprint is very convenient. Yes. If we use, there may be other ways for us to pay the money, but I think use our face or fingerprint is very convenient. Yes. Maybe we can also use our footprint. Yes. But it is not convenient. And the user's expectation will not be met. Okay. So for interactive system, we should pay attention to users' expectation. Okay. The real-time system, there are also two goals. The first is meeting the deadline. I just put a deadline, and before the deadline, the computer system just can finish the task. Yes. Okay, let's learn some specific algorithm. The first one is first come, first
served.
I think this is a common method. Yes.
Yeah.
And just like we
Queue.
some yes queue.
Yeah.
Yes. 排队，对不对？ Buy something. Buy something in the market. Yes.
Yeah.
You come first, then your work is sold first. Yes. The process is also the process that comes first. Your work is sold first. Yes. It is a common idea. Okay. Just like make things in our life. Yes. We just learn the second one. The second one is shortest job first. Shortest job first. So we just compare their time for completing this process. We compare their time. Yes. We first saw the process requires the shortest time. Yes. For example, there is a figure. In this figure, there are 4 processes. Process A, process B, C, and D. The number about the process is just the time required for completing this process. For example, process A requires 8, yes. Process B requires 4. Process C and D also require 4, yes. So we can compare these 2 scheduling. In the first scheduling, we first saw process A, then B, then C, then D, and maybe process A comes first, later B, later C, and D last. Okay. In the second one, we can see that we first saw process B, and then C, then B, then A. Okay. The time required for a specific process is given. Okay. So we can compare these 2 scheduling. We just compare these 2 scheduling. Which one is better? And why? Which one is better and why? The second one is the shortest job first. Yes.
Yeah.
Which one is better? Maybe we can discuss from different perspectives.
Yeah.
Okay.
If I think about time, they are in a time.
Okay.
Time. 时间
time. Okay.
If I think the time in the A, first job is double.
You will just focus on this scheduling.
Yeah.
Yes. Okay.
Yeah. In same time, in the B we can do 2 tasks.
Okay.
Yeah.
B first.
Yeah.
And then C.
Yeah.
So which one is? I mean, these 2 scheduling. Maybe we can find some advantage in the second one.
Yeah.
So tell me the advantage. Just think about it.
Because in there like
which advantage you can find in this scheduling? It is just rational, it's okay.
Yeah, I know. When I am doing with A, in the A is 8, right?
8, yes.
But
this time
in the
8.
yeah, in the B
Require 4.
You require 4. 4, I can do 2 tasks. 4, 4, 8.
Oh, yes, yes.
Yeah.
Yes, that is, it is very good. You just means, in the first one, when we use 8 time, we can only finish task A.
Yeah.
Yes, in the second one,
we can complete task B and C.
Yes, we use 8 time and we can complete process B and C. Yes, it's very good. Yes, this is the advantage. Okay. So we in the same during the same time we can finish more tasks. Yes. This is why we first show the shortest job. Okay. Yes. We can compute the waiting time. We can compute the waiting time for each task, for each process. Now this is the process. The first thing, I think we all know that if we want to finish the 4 process, we require the total time is 20. Yes. If we want to finish all 4 processes, we require 20 time. Okay. And next one, we just compute the waiting time for each process. We can see that 4 processes in A scheduling, first scheduling, process A requires
8.
You can see A is just 8, yes, and E is just 12, okay. Then C is just 16, okay, and D is 16, is 20. Yes. We can compute the average time is divided by 4. Okay. And then the second one, the first process is B, is just 4, okay, and C is just 4 plus 4 is 8. Okay, E is just 8 plus the time for B. And 8 is just is 20. Yes. So we can compute the average time is 4 plus 8 plus 12 plus 20 and divided by 4. Okay.
It's 11.
This is the sum. This is divided by 4. We just compare these two.
First one is 14.
Yes. How many?
14.
14, okay.
Second one is 11.
11. So we can see that the average time for the second scheduling is shorter. It's short. Okay. one is that all these processes are already in ready state. It is in ready state. Okay, and it means that if the CPU calls and this process can be executed. Okay, it's in ready state, not blocked. If we can consider another condition. If the process A is just waiting for I/O, it is blocked. So similarly, this process B is waiting for I/O. Even we want to process B at first, but we can't because it is waiting for I/O. It is blocked, not ready. Yes. So the shortest job first, there is the condition that each process is in ready state. Okay. Okay. Ms. Tamaris. We have just learned two types of scheduling algorithm. The first solve, yes. The process comes first, will be solved first. The shortest job first, it means that the job with the shortest time will be solved first, yes. There are also some other scheduling algorithms. For example, robin. I ask we are familiar with robin, yes. Robin.
Yeah.
For example, output is first, and then
sample,
and the next
毛节
and again output sample 毛节. Yes, this is the robin. Okay. For example, there are 5 processes A, B, C, A, E, F, B, G. Yes.
Yeah.
The first one is
B,
process B. Yes. Next is F, B, G,
C,
A. Okay. When B has finished or its time is enough, then we begin F. Yes. And B is
in the last.
Or at the end. Yes. So the list is F, B, G, A, B. Okay, this is the robin. The next one is priority scheduling. So it means that we schedule processes according to their priority, and just like in the market, maybe some customers are very important. Reactive. Yes. If you want to buy something, or maybe some customers are VIP, very important, reactive. So these customers will be sold first because they are VIP. Okay, this is also the same idea. We just group the processes into multiple groups. Yes. This is the first group, the second group, the third one. Each rectangle here represents a process. This is the priority 4. This group its priority level is 4. And the second one, the priority level is 3. How better? The how the better. So priority 4 means the highest priority. It means that given these processes, we should first solve processes with priority 4. Yes, because the priority is the highest. And so we first solve this group. First solve this group. If the priority for group has finished.
Three process.
Yes, then priority 3 group. Then priority 2 group. Priority 4, it is just a group. We can see that there are 3 processes. So in each group, there are different scheduling algorithms. For example, in the same group, maybe we can use round robin. Yes. Process A, process B, process C, then process A, process B, process C. Okay. In the same group, maybe we can use round robin. After we have finished all processes in the same group, then we begin to the next group. Okay, it means that processes in priority 4, all these processes have finished. Then we begin tasks in priority 3. Okay, another group. And in the same group, we can use round robin and just divide the processes into groups. Okay, this is the priority scheduling. We have learned some algorithm about process scheduling. This algorithm can also used for thread scheduling. Okay, I just mean that this algorithm we just talking about process. Yes, scheduling algorithms for process. Yes, in fact. This scheduling algorithm can also use for threads and 进程, 线程. Okay, can also use for thread. Yes, we can also use this algorithm. Okay, there are more things I have to stress. We learned that. The process may be run in user mode or in Cleo mode. Okay, I write down. For process, okay, in user mode or in Cleo mode, okay. If you just in user mode, it means that the operating system can only manage the process, but the operating system doesn't see thread. Okay, for example, here. This is in the user mode. So the operating system, the Cleo, only say process, but this one doesn't say thread. He doesn't know thread, but only know what processes or many and what are they. Okay. Differently, if in Cleo mode, in this one. The operating system can directly manage thread. Okay, so let's return back to this figure. Just run in user mode. So it means that the Cleo can only pick a process. The Cleo can't pick a thread. Okay, is there any problem? Yes. Okay. The Cleo just pick a process. it doesn't know any thread. Well, for example, the kernel picks process A.
Kernel only know the process.
Yes, no process.
Yeah.
He just see process.
Yeah.
I like just see you back. I don't know to see you back.
Yeah.
Okay. So I just prepare you and just take it back. Okay. So the kernel picks a process. The kernel can determine which process to run. Maybe process A,
process A or process B.
Or process A, okay. But it can to pick a thread. Okay. So the process A manage its thread. Yes.
Yeah. Their runtime system.
Yes, the runtime system. We have the runtime system just pick a thread. Yes.
Manage the threads.
Yes. And there are three threads. Okay. Maybe thread 1. Yes. Maybe thread 1. This is A1. A1 means thread 1.
Thread 1.
This is the thread. Thread A1, thread A2, thread A3. The first factor is A, so it means that the thread is in process A. Okay. On the contrary, this B3, it is also a thread, but in process.
In process B.
Yes, correct. So the runtime system, we can see that in the first picks process thread 1, then thread 2, thread 3, thread 1, thread 2, thread 3. Yes. Okay. We can see that there are the total time is 15 milliseconds. Okay, the total time is 15 milliseconds, and the quantum just like in here, round robin quantum 时间片 quantum. You can see that the quantum is the same as. Quantum means a period of time. Okay. The total time is 15 milliseconds, and each thread requires 5 milliseconds. Okay. 5 milliseconds. So in 15 milliseconds we can run 10 threads, yes?
Yeah.
Each one 5 milliseconds, and there are total 15 milliseconds, so 10 threads, okay? Because this is 15 seconds, so we just process A just run its threads. Process A didn't finish its task, so process B will not start. So this list is impossible. It's impossible because this is only 5 milliseconds, and then we switch from process A to process B. But in fact, there are total 15 milliseconds. We will not switch, yes? So this list is not impossible. Okay. This is run in the user mode. On the contrary, if run in the clear mode, I just say that in clear mode the operating system see and know threads, yes. So the operating system can manage the thread, yes. So the clear picks a thread instead of a process.
Yeah.
Not a process, okay? The clear directory is accelerated. So the clear C is this rate, not process. It's just scheduling among threads instead of process. Yes. So and in the following list, maybe the clear fosters pick a thread 1 from process A, and then a thread 1 from process B. Yes. Process thread 1, thread 1, thread 2, thread 2, thread 3, thread 3. Okay. Anyone. Because the kernel can directly pick a thread. Okay. So the difference is obvious. Yes. Let's learn more things about the switch from one process to another process. In this figure, suppose that each quantum is 4 milliseconds. Okay, and this line, we switch from one process to another process. Okay. Switch require 1 millisecond.
Yeah.
1 millisecond. So we can compute the CPU utilization. CPU utilization for milliseconds, yes, for working, and the total time is 4 plus 1. Yes, so this is 18%. It means that in a cycle, 18% of the time is working. Okay, so the wasting time is 20%. Yes, because 1 millisecond is used for switching. Yes, this is waiting time. This is the CPU utilization. Okay. If we just change the length for quantum, it means maybe we can increase this one. For example, maybe this can be 100 milliseconds. Okay, so we can also compute this one. Waste. Okay, it is 1 millisecond divided by 1 plus 100. Yes. This one is about 1%. So we can get that if the quantum is short, the short quantum, we can get that we waste about 20%. Yes. This one, the quantum is 4 milliseconds. Okay. The quantum is 4 milliseconds, and we can compute that about 20% time is wasted. We waste 20% time, yes. and then we change the length of the quantum to 100 milliseconds, and we compute, we can get that the percentage becomes 1%. Yes. So which one is better? Which one is better? 20% or 1%?
1%.
Yes. We only waste the 1% of our time. So this one is better. And the reason for this one is because the length of quantum is bigger. Okay. So maybe we think that if we increase the time for quantum, then this time is waste, and the CPU utilization will be larger. Okay, but there is a problem. For example, if there are 15 processes, and the quantum is 100 milliseconds. So the first process requires 100 milliseconds. Okay, then we switch to another one. This one is 1 millisecond. Then we continue. The second process is also 100 milliseconds. Okay, then switch for 1 millisecond, and so on. Then we can get that the 15th, the last one, we are waiting. Waiting time is 100 milliseconds and multiplied by 15. It is about 12 seconds. So it means that the last process we are waiting a long time. Yes, 12 seconds. So it is not a good thing. The last one we are waiting a long time for executing. Yes, it is not a good thing. So how to determine the length of a quantum is an issue for research. Although another one can increase the CPU utilization, but it will increase the response time. It is not a good thing. So from the example, we can get that the length of a quantum can neither too long nor short. Yes, a problem. Okay. So in real applications, this one, the length of a quantum is about 20 to 15 milliseconds. This is a problem. Okay. Too long is not a good thing. Yes, because we can see that the response time will increase. Okay. The last one is about the dynamic philosophical problem. It is also a classical problem. Maybe we can learn in this lesson we learn some basic information about this dynamic philosophical problem. First of all, we know what's the problem. we can see that this is a circular table. Yes, circular table. Okay, and then five philosophers sit. We can see there are five plates. Yes, 1, 2, 3, 4, 5 plates, and each plate for each philosopher. The philosopher sitting beside the table and want to eat. Yes. Maybe the food in the table is spaghetti, 通心粉，意大利粉。So if you want to eat the spaghetti, you need 2 forks. Just like Chinese people want to eat something. Yes, 2根筷子 2 chopstick. Should be 2. Okay.
一双，
很好，是一双。Yes. So if the philosopher want to eat the spaghetti, he should pick up 2 forks.
Yeah.
It means that the philosopher can eat the spaghetti if and only if he gave it 2 forks. So we can say how many forks?
5.
Yes, 1, 2, 3, 4, 5 forks. 5 forks, 5 philosophers. Yes. So we can imagine what will happen. Just imagine 5 persons seated beside the circular table, and each one wanted to pick up 2 forks, then eat the spaghetti. Okay, you can see that 1 fork is between 2 philosophers.
Yes. They maybe.
Maybe one wanted the fork, and some also wanted the fork. Yes. Yes. So if you want this fork and another person also wants this fork, then
there may be decision will pending, because which fork will take.
Which person should pick up the fork and then eat?
Yeah.
Yes.
Yeah.
This is the problem. Maybe each one just pick up the left fork.
Yeah.
5 philosophers, and each one pick up the left fork.
Maybe someone left, someone right.
Yes.
That time it will conflict.
Maybe someone left, someone right.
Yeah, yeah.
So we just think if each one pick up the left fork and then no one will have the foot. Yes. 好，我们就上这个。
好。
等一下，我发现接不了，因为我教室里另外一个老师在哪了嘛，我只能在这里上。
Siya kasi ba?
Okay, that's all.